In the last video, we got to see how an ANOVA can be useful, or a one-way ANOVA can be useful for looking at how one factor can affect different groups. So in the last example, we looked at the placement of books in the bookstore, whether that was front, middle, or back. In this example, we want to look at two different factors to see how they would affect a sales forecast. So in this particular example, we are going to look at how the sales, or we're going to look at the sales representative and the district that they were assigned to. So there are 4 sales representatives and there's 5 districts. Each sales representative was assigned to each district one time. This means that it's going to be a two-way ANOVA without replication. If, for instance, they had been assigned to the same district 2 times or more, then it would be a two-way ANOVA with replication. But because each representative was only assigned to each district one time, it is a two-way ANOVA without replication. The same as a one-way ANOVA, our null hypothesis here is going to be that there is no difference between the groups based on the representative or the district. And if the data proves that that is extremely unlikely, then we will reject the null hypothesis and we will go with the alternative hypothesis that there is a difference between the groups. All right, so here's how you run the ANOVA. You go to your data ribbon, go to data analysis, go to ANOVA, two-factor without replication. Our input range here is going to be A1 through E6, okay, and there are labels, so make sure that you check that box. If you've included labels, make sure you include them or exclude them consistently, or it will throw off your data. Our output range, I'm going to make cell A9, and here we go. All right, now we have a bunch of great data, and so the question becomes, again, what do we do with this beast? Well, the first thing that we need to look at is the p-value for the rows and columns, and I'm going to make these numbers again so the exponents don't confuse you as to whether or not these are significant. We have got to make sure that both the rows and the columns are significant or not, and your book has them significant if they are 0.15 or less. That would be the 85% confidence rate interval. Generally, standard is the 95% confidence interval, and so that would be 0.05 or less. It kind of doesn't matter in this case because both of them are indeed less than 0.05. What you need to do is state up front what confidence interval you're using to determine the significance. So what this is telling us is both the data in the rows, which the data in the rows is the districts, and the data in the columns, which is the representatives, are significant in predicting sales. So there is a significant difference in the groups, and it is significant both on rows and columns. So now, what if we wanted to predict the sales for representative 4 when they were assigned to district 2? Well, first of all, we need some more data. We need to calculate some more data in order to be able to do this. First of all, we need the standard deviation, and that is going to be the square root of the overall mean squared. So this 15.5925, we need the standard deviation for that. Okay? So we start our formulas with an equal sign, and then we start typing in the formula, or the symbol for square root, which is SQRT. And parentheses, we select that number, and so you should get your standard deviation is 3.99. All right, the next thing we've got to do is we've got to see how each of these varies from the average. So we need an overall average of all your data. So I'm just going to type in average. I'm going to select the entire block of data, and you should get, when you do that, you should get 17.6. Now what we're going to do is take that 17.6 and we're going to subtract the average of each one from that 17.6. So your first one, oh, I'm sorry, you know what? We're doing it the other way. We are taking the average and of the individual line, and then we're subtracting the overall average. I did that backwards. All right, so you should have negative 11.1. And you know what I'm going to do is I'm going to go back and make this B7 an absolute value, and then we can just copy and paste this formula all the way down. All right, so this is how the average of each group differs from the overall average of all of the data. So now to do the average for representative 2 for district 2. Okay, so we are going to take the overall average plus the average for representative, I'm sorry, it was representative 4 in district 2. So now we're going to grab district 2 and representative 4. Okay, so we are going to take the overall average plus this deviation for district 2 plus this deviation for district 4. Now, notice this is negative. I always do plus here anyway, because if you, it ends up being a minus. If you do plus, if you do minus and then it's minus, this number is negative 2.48, you end up essentially adding it, right? Okay, so you should have the average here as 18.35. Now we want to know the lower end of our 95% confidence interval, and so we take this average and we subtract 2, oh, I'm going to put that in parentheses, 2 times the standard deviation. Okay, and then for our upper end of our confidence interval, we're going to take the average and we're going to add 2 times the standard deviation. So you can be 95% sure that if you assign representative 4 to district 2, that their sales are going to be 10.36 on the low end to 26.33 on the high end, with an average of 18.35. So we could do this for any of the districts or representatives that we wanted to, or all of it. It could be a really useful tool for a sales manager to figure out their predicted sales. Okay, as always, I hope this video has been helpful. If you have any questions, please feel free to contact me, and hope you have a great day.